Okay, so let's move on to number 1.3. Number 1.3, they want us to work out the height of the the building that the person is tossing the stone from, or throwing the stone from upwards and downwards. They want to get you to get this height. Now, how would you do that? Obviously, you could find out what the speed will be of this stone B when it hits the ground. Okay. Or you could find out what is the time that it takes for stone B to get down to the ground. So there's many ways that we can approach it. Okay. So let's see what further information they provide us with. What they say is when stone A passes again at the original point where it was tossed up, so up, comes down. When it comes there, back to its original point, then the ball B would have hit the ground. So we can work out the time that it moves up and come down. We've already got the time that it takes to move up, that's 1.22 seconds. To come down, same time, so it's 2.44 seconds to go up and to come down. By that time, ball B would have hit the ground. So that is the time that it takes. So we have the initial speed now. We've worked that one out. Okay. And we want to work out what is the height from that to that. Let's see how we can approach this problem. Let's stick to our upwards. Being positive. Alright, so that's important to write that down. What do we have now? So let's take stone B. Okay, for stone B to go from this point there, from its initial point to the ground, the time is same time that stone A is tossed up and passes its original point, which will be 2,44 seconds. How do we get that? We say it's 1.22 seconds to go up to the maximum height, another 1.22 seconds to come down back to its original place where it was tossed up. So it's 1.22 multiplied by 2 gives you 2.22 seconds. That's the time that ball or stone B reaches the ground. So that's the time. What is the value for G? It's minus 9,8 meters per square second. What else do we have? The initial velocity, yes. Initial velocity, I think we worked that one out as 5,98 meters per second. So now we have that, and we've got the time. What don't we have? We don't have delta y. That's what we need to find out. That's an unknown. Is there maybe a formula that we can put in there? Let's look at that. Okay, so we have our formula, delta y, that's what we need to get, is equal to VI, the initial velocity multiplied by t plus a half gt squared. That's the formula that we can use. Let me just change this one here. That's VI. Okay, and then we substitute. So VI, remember, it's downwards, so it's minus 5,98. Okay, multiplied by the time, 2,44 seconds, minus, or in this case plus, multiplied by minus gives you a minus. So it's minus 0,5, which is half, times 9.8 times 2.44 squared, and the answer is minus 43.76 meters. And that's your substitution, and get your answer for that. Okay, listen to the video once again, over and over, and make sure that you understand. If there's still problems, you can contact me or ask questions in class before we go on to the next chapter. Okay, and so that's the total distance from the ground if we use stone B. We could use other methods, but that's the easiest one that we can use. Okay, we could also use stone A as it returns. So it takes, we can work out the total distance that it travels up and down to its original point and then to the ground. We can also do that, but it's easier to just work with stone B. They could also have asked you what the velocity of stone B would be, the final velocity of stone B, and that could also be worked out. Well done. Alright, listen to the last video. That will give you an indication how to plot the graphs.